A student raises his hand in my lecture room and the question forms before he can stop it. I'm afraid I don't understand. 4 words carrying more weight than their sound suggests. Because what he means is not that this particular equation has eluded him or that he has lost the thread of the last 10 minutes. What he means is that he is standing on ground, he cannot feel that the calculus or the quantum mechanics or the differential equations have passed through his mind without building anything solid, and tomorrow there will be an exam that measures whether the solid thing exists. What he means is, make it stop moving. What he means is, tell me when it will feel like the other things I know, the things I trust, the things that stay known, and the answer he wants, the answer he thinks he deserves after attending the lectures and reading the textbook and working the problems is that understanding will arrive. That this sensation of skating over frozen water he cannot see through is temporary. That one more explanation, one more worked example, one clearer analogy will be the one that makes it click. And after that click, the knowledge will be his in the same way his native language is his, automatic and immovable and requiring no vigilance to maintain. The night before an exam is when this request becomes impossible to honor. There is no time remaining for understanding to arrive. The exam is in 8 hours. In 8 hours, he will sit in a room with a paper that asks him to demonstrate possession of something he does not possess, and the institutional apparatus does not grade effort or good faith or the sincerity of his confusion. It grades answers, so the question sharpens. Not when will I understand, but what do I do with the fact that I don't? There is a story people tell about me, repeated in mathematics departments for 70 years, sometimes as a joke, sometimes as a koan, sometimes as a piece of advice so brutal it sounds like pedagogical malpractice. A young physicist came to me the night before a deadline that carried the weight of an exam. He said, I'm afraid I don't understand the method of characteristics. And I said, young man, in mathematics you don't understand things, you just get used to them. The line sounds like dismissal. It sounds like a genius telling a non-genius that comprehension is for lesser subjects, that mathematics is inherently beyond reach, that some people have access and others don't. It sounds like the kind of thing you say when you've never experienced confusion yourself, when understanding arrives for you as effortlessly as breathing, and you cannot fathom why others struggle. But that is not what I meant. And the context matters. The physicist did not leave that conversation unable to work. He left it able to work. The advice functioned, which means it was not dismissal, it was something else. What it was, a description of what knowledge actually is in mathematics and everywhere else, delivered by someone who had looked carefully enough to see it. Consider what you think you understand, not mathematics. Start with something simpler. You understand how to walk. You have been walking since you were 14 months old. If I ask you to walk across this room, you will do it without conscious thought, without needing to calculate the angle of your ankle or the precise force required from your quadriceps or the balance adjustments happening in your inner ear 30 times per second. You will simply walk, and if I ask you whether you understand walking, you will say, yes, of course, obviously. But if I ask you to explain it, to articulate the process in language that would allow someone who has never walked to reconstruct the action from your description, you cannot. You can say some things, you shift your weight forward, you put one foot in front of the other, but this is not an explanation, this is poetry about walking. The biomechanics textbook will give you more. The role of the cerebellum, the firing patterns of motor neurons, the complex feedback loops between proprioception and muscular adjustment. But even the textbook is not explaining walking, it is cataloging observations about walking, naming components. And if you read that textbook cover to cover, you will not understand walking in any sense that differs from what you possessed at age 2. You will have gotten used to different language about it. The action itself, the knowledge that allows you to cross the room, remains exactly as mysterious and exactly as functional as it was before you knew the word proprioception existed. This is not a failure of the textbook, this is what knowledge is. Familiarity that runs deep enough to be operationalized. You can walk and you can talk about walking and you can even predict certain things about walking, but the thing you are doing when you do it is not understanding. It is an intimacy with a process that has stopped requiring explanation. You have gotten used to it, and we call that understanding because we need a word for the thing that works, and we have confused working with comprehending. I think about driving. I know people who have been driving for 20 years. They can merge onto a highway at 70 miles per hour in moderate traffic without incident. They do this by making 1,000 micro adjustments per minute, accelerator pressure, steering angle, gaze direction, distance estimation, speed matching, threat assessment. If you watch their hands and feet during this process, you will see motion so fluid it looks automatic. And it is automatic. But automatic is not the same as understood. If you ask them to write down the algorithm they are executing, they cannot. They can drive the car, but they cannot fully specify what they are doing when they drive it. They have 7,000 hours of practice and 0 hours of understanding in the sense they claimed to want when they first sat behind the wheel. They have gotten used to the car. It is enough. It is, in fact, all there is. The pattern holds everywhere. You speak your native language with grammatical correctness you cannot articulate. You make ethical judgments using principles you cannot fully enumerate. You recognize faces using criteria you cannot specify. You do mathematics, everyone does some mathematics. Even if it is only arithmetic using relationships, you have stopped questioning. 3 times 4 is 12 is something you know the way you know how to swallow. It is not something you understand. It is something you have done enough times that the action and the answer have fused. The space between the question and the response has collapsed. You have gotten used to it. And this, I think, is what I had seen. That mathematics is not exceptional in its resistance to understanding. Mathematics is exceptional in its refusal to pretend that familiarity is something else. In biology, you memorize the Krebs cycle, and then you take the exam, and then you continue to use the phrase Krebs cycle as though you understand cellular respiration in some complete way. In history, you learn that the Treaty of Westphalia ended the 30 Years' War, and you carry this as knowledge, even though the thing you possess is a sentence, not comprehension of the political, religious, and economic forces that converged in 1648. We permit this. We call it education. We agree collectively not to pull the thread that reveals how thin the fabric is, but mathematics does not permit it. Mathematics has proofs. Mathematics has logical dependencies. Mathematics will not allow you to use a theorem you cannot derive or invoke a principle you cannot justify. Or rather, it will allow it. It allows it constantly, but it never stops reminding you that you are doing it. The gaps stay visible. The foundations remain exposed. You can calculate a derivative using rules you memorized, but the textbook contains the epsilon delta definition, and the definition is still there on the page, waiting, and you know that what you are doing is not understanding calculus, but operating a mechanism you have learned to operate. You have gotten used to the derivative. You have not understood it. Mathematics is the only field honest enough to let you see the difference. This is not a bug. This is not mathematics failing to be a teachable subject. This is mathematics revealing what teaching actually accomplishes in every subject. It produces familiarity. It produces facility. It produces the ability to manipulate symbols and execute procedures and generate results that are quite often correct. What it does not produce, what it cannot produce, what it has never produced for anyone in any field is understanding in the sense of complete, transparent, unmediated access to the thing itself. That understanding is mythological. It is the story we tell students to make them believe their confusion is temporary. I stopped telling that story, not because I wanted to be cruel, because it was false. The exam is still in 8 hours. The question is still what to do with the confusion, and here the advice becomes practical. Because if understanding is not coming, if understanding is not a place you arrive, but a story you tell about familiarity after familiarity has done its work, then the task is not to achieve understanding. The task is to increase familiarity until it becomes functional. The task is to practice the operations until they stop requiring justification, to work the problems until the patterns become visible, to execute the procedures until the method becomes automatic. This is not a substitute for understanding. This is what understanding has always been in every domain for everyone. You will not walk into that exam room tomorrow with transparent comprehension of Maxwell's equations, but you can walk in with enough familiarity that you can deploy them. You can recognize which equation applies to which situation. You can execute the solution procedure. You can arrive at an answer that is correct, even though the correctness is not accompanied by the feeling of certainty you think you deserve, and the exam will not know the difference. Because the exam is not measuring understanding, the exam is measuring function. Can you do the work? Can you produce the result? Can you operate the machinery of physics whether or not you have achieved philosophical peace with what the machinery is? This sounds like I am telling you to give up. It sounds like I am saying that physics is impossible and mathematics is impossible, and you should lower your expectations and accept that confusion is permanent. But I am not saying that. I am saying that confusion is not the thing you think it is. Confusion is not the absence of understanding that will someday be filled. Confusion is the noise that familiarity quiets. And familiarity does arrive. It arrives through repetition and exposure and time spent inside the material. It arrives slowly and without announcement. One day, you are working a problem and you realize you are no longer translating from English into mathematics. You are simply doing the mathematics. The symbols have stopped being foreign. The operations have stopped requiring justification. You do not understand them in some final, complete way, but you have gotten used to them. And getting used to them turns out to be sufficient for everything understanding was supposed to accomplish. The students who fail exams are not the students who lack understanding. No one has understanding. The students who fail are the students who never developed familiarity because they were waiting for understanding to arrive first. They read the textbook waiting for the click. They attend the lectures waiting for the moment of clarity. They do not practice because practice feels like admitting defeat, like conceding that they have failed to grasp the concept and must now resort to mechanical repetition. But practice is not the consolation prize. Practice is the mechanism. The students who succeed are not smarter. They are not more capable of abstract thought. They simply started practicing earlier before they understood, because they recognized, consciously or not, that practice does not require understanding as a prerequisite. Practice produces familiarity. Familiarity produces function. Function is what we were calling understanding all along. I watch this happen every semester. Two students sit in the same lectures, they hear the same words, they read the same textbook. One of them begins working problems immediately, while the material still feels foreign and threatening. The other waits for it to make sense, waits for the pieces to cohere, waits for the feeling of readiness that will signal it is now safe to begin practicing. That feeling never comes. And so the second student arrives at the exam having read everything and practiced nothing, and discovers too late that reading produces recognition while practice produces capability, and the exam is measuring capability. The equations on the exam look familiar, yes. I saw those in the textbook, but the hand does not know what to do with them. The recognition is passive. It cannot be deployed. The first student arrives at the exam with hands that have written these equations 40 times. The understanding is not deeper, the intelligence is not greater, but the familiarity is operational. The exam asks a question and the hand begins moving before the conscious mind has fully parsed what is being asked. This looks like intuition, it looks like natural talent. It is neither. It is repetition that has carved channels deep enough that the work flows through them without requiring the constant supervision of conscious thought. This is what expertise is in every field. Pattern recognition that has become automatic through exposure. The chess grandmaster who sees the board and knows the move is not computing possibilities faster than you. They have seen this configuration before, or configurations sufficiently similar, enough times that the response has become immediate. They have gotten used to it, and here is what matters. This is not inferior to understanding. This is not the thing you settle for when understanding is unavailable. This is what understanding is in every domain where the word applies. The surgeon who can perform an appendectomy without conscious thought about which instrument comes next has not transcended understanding. They have gotten so used to the procedure that it has become automatic. The musician who can play a Chopin etude without reading the score has not understood music in some mystical way unavailable to others. They have practiced that piece hundreds of times until their fingers know it independently of conscious instruction. We call this understanding because it produces correct action reliably. But the mechanism is familiarity. The mechanism is always familiarity. There is no other mechanism available. And recognizing this removes a burden students do not know they are carrying, the burden of waiting for transformation. The burden of believing that somewhere ahead, if you just find the right explanation or the right teacher or the right moment of clarity, there will be a discontinuous jump where confusion becomes certainty, and from that moment forward the knowledge will be yours without effort. That moment does not exist. What exists is the gradual accumulation of familiarity through exposure, and at some point the familiarity becomes sufficient for the task in front of you, and later it becomes sufficient for harder tasks, and eventually it becomes so deeply established that you forget you ever found it foreign. But there was no moment of transformation. There was only time and repetition and the slow reduction of the friction between the problem and your ability to engage it. When students arrive the night before the exam still waiting for that transformative moment, what they need is not a better explanation. What they need is permission to stop waiting, permission to recognize that the discomfort they feel when working problems they do not fully understand is not a sign they are doing it wrong. It is the feeling of familiarity being built. It is what learning feels like from the inside. And it does not go away when understanding arrives, because understanding is not arriving. The discomfort diminishes as familiarity increases, but it never reaches zero. I have been doing mathematics for 40 years, and there are still moments when I'm working where I cannot articulate why the next step is correct, even though I know it is. The knowledge exists somewhere my verbal reasoning cannot reach. I have gotten used to this. It works. I knew this because I had watched mathematics itself go through the crisis. In the 1920s, two mathematicians, Brouwer and Weyl, both of enormous stature, argued that the foundations of mathematics were not rigorous enough, that the proofs mathematicians had been writing for centuries contained hidden assumptions and logical gaps. They proposed new, more restrictive standards for what counted as a valid proof, and mathematics faced a choice. Most mathematicians looked at the new standards and said, these are probably correct, but if we adopt them, half of existing mathematics becomes invalid. Theorems we have been using for 100 years would need to be discarded or reproved under new rules, so they did not adopt them, they kept working in the old system. And Hilbert proposed a justification. Maybe we can prove, using the strict new rules, that the old system never leads to contradictions, that even though the old proofs are not rigorous by the new standards, they are at least consistent, they do not produce results that conflict with each other. And then Gödel proved that this is impossible, that if a mathematical system is consistent, its consistency cannot be proved within that system, which meant that the hoped-for justification was unreachable. Mathematics could not prove its own reliability, and mathematicians faced a second choice: stop doing mathematics or continue doing mathematics knowing that you cannot prove the foundation will not collapse. They chose to continue, not because they proved the foundation was safe, because the foundation had been functioning for centuries and showed no signs of failure. They had gotten used to it. And getting used to it was, it turned out, enough. This happened in my lifetime. I watched it happen. I watched mathematicians, myself included, change our minds 3 times about what constitutes certainty, and then keep working anyway, and the work continued to function. The theorems continued to be correct. The applications continued to produce results. Mathematics kept operating even after the philosophical ground beneath it had been revealed as unprovable, because mathematics does not run on certainty, it runs on familiarity rigorous enough to be formalized. And if mathematics, the field that demands proof for everything, can function without certainty, then physics can, then everything can. The exam tomorrow is not asking whether you have certainty, it is asking whether you have familiarity. And familiarity is achievable in the time remaining, not through understanding, but through doing. Through working problems until the steps become automatic, through writing out the equations until your hand knows the motion, through repeating the procedures until they stop feeling alien. This is not a trick to get you through the exam despite your ignorance. This is how knowledge has always worked, including for the people who wrote the textbook. They do not understand Maxwell's equations in some deeper way than you. They have spent more time with them. They have gotten more used to them. The difference is quantitative, not qualitative, which means it is closable. You will not close it completely in 8 hours, but you can close it enough. And after the exam, you will continue closing it, not by seeking understanding, but by continuing to practice, continuing to expose yourself to the material, continuing to do physics until physics stops being something you do and starts being something you are. This transition never involves understanding in the mythological sense. It involves familiarity so deep it feels like understanding, and we permit ourselves to call it understanding because there is no other word available, and because the feeling is real even though its cause is not what we think. I think about the students who will walk into the exam room tomorrow morning. Some of them spend the night desperately rereading the textbook, hunting for the explanation that will make it all make sense, waiting for understanding to descend. They will walk in exhausted and still confused because understanding did not come, and they will struggle. Some of them spend the night working problems. Dozens of problems, not because they understood the method, but because working the method is what you do with the time you have. They will walk in with hands that remember the motion of the equations. They will see a question and recognize its shape. They will execute the procedure. they will get the answer, and if you ask them afterward whether they understood the material, they will not be sure, because what they have does not feel like understanding. It feels provisional. It feels like something that could slip away if they stop practicing. And they are right. It could. Familiarity requires maintenance. This is also true of everything else you think you understand. Your native language would degrade if you stopped using it. Your ability to walk would diminish if you stopped walking. Nothing you know is permanent in the way the word knowledge implies. Everything is familiarity that persists as long as you keep doing it. This is not a comfortable thought. It means you are never finished. It means there is no moment where you achieve understanding and get to stop working and simply possess the knowledge from that point forward. It means that everything you know is something you are actively doing, right now, continuously, and if you stop doing it, the knowledge will dissolve. But it is also a liberating thought, because it means you do not need to achieve understanding before you begin. You can begin now. You can begin confused. You can begin uncertain. You can begin without the feeling of solidity you think you need, because the solidity was never available to anyone in any field. What is available is the work, and the work produces familiarity, and familiarity is all anyone has ever had. The exam tomorrow will ask you questions. You will not fully understand the questions. You will answer them anyway. You will write equations you have gotten used to writing. You will execute procedures you have gotten used to executing. Your answers will be correct or incorrect based on how much time you have spent with the material, not on whether you have achieved philosophical peace with it. And this is true of every exam, every assessment, every measurement of knowledge in any domain. We pretend we are measuring understanding, we are measuring familiarity. The students who recognize this early have an advantage, not because they are smarter, because they have stopped waiting for permission that will never come. Morning arrives, the exam room door opens, you walk in, you do not understand, you have stopped waiting to, you have equations that feel almost familiar. You have procedures, you have practiced enough times that your hands know them, you have definitions, you have read enough times that you can reproduce them. None of this feels like certainty, all of it is enough. You begin writing, the work proceeds, not because understanding arrived in the night, because you have gotten used to it, which was always the only destination available in mathematics, in physics, in everything you will ever know.